Previously on Physicsball Z, our heroes journeyed to the twin circuits of series and parallel circuits, and they learnt what happens to current and potential difference in each scenario. And just when they discovered how resistors work in series and parallel circuits, they were attacked by this past paper question. But by using the ancient highlights and the sacred equations, they were able to calculate this monstrosity of a question. And now, our heroes have uncovered the hidden base of mains electricity. Will they be able to pattern direct and alternating potential differences, or will their energy supply be limited? Find out in today's episode of Physicsball Z. Here are the retrieval questions for this lesson. You know what to do. Ammeters are connected in series. Voltmeters are connected in parallel. Arteries are blood vessels that take blood away from the heart. Veins are blood vessels that take blood to the heart. Covalent bonds are shared pairs of electrons. Ionic bonds are electrostatic attractions between oppositely charged ions. Here are two different types of circuits and a light bulb. Have a go at these challenge questions based on these three pictures here. The diagram shows that an alternating current should be B. We can see that the electrons are moving back and forth, they're alternating their direction. Therefore, that must mean that the direct current must be A, because you see the electrons just flowing in one direction. The light has been slowed down, and this is actually how they are in your house. It's just that they flicker so fast that you can't notice it. The only one of these circuits that can cause this flickering is an alternating current. This is because the flickering is when the direction of the current is actually changing. So summarizing this, DC is a direct current and that's flowing in one direction. AC is an alternating current which repeatedly changes its direction. This is a picture of the back of a TV, and the top shows some units that we need to match up. You need to look carefully at the label to answer the other two questions, the more challenge and the mega challenge, okay? So have a go at that. Current is measured in amps, potential difference is volts, and frequency is hertz. The maximum potential difference here is 240 volts. The maximum frequency is 60 hertz. Any electrical device that you have in your house will display the potential difference, the frequency, and also the power that it can take. There are three standard pieces of information for electricity coming out of a UK socket. First, it's an alternating current, so the electrons are moving back and forth, they're repeatedly changing directions. The potential difference that's coming out of it is 230 volts, and also this occurs at a frequency of 50 Hz. Look at these two graphs now. Both have the potential difference on the y-axis and time on the x-axis. Can you work out which one is showing the alternating current? Of course, A is showing the alternating current. When the current is moving in the forwards direction, the voltage is positive, but when the current is moving in the backwards direction, it becomes a negative. The plugs in the UK have 3 pins. The outer casing is made from a hard plastic, and the pins themselves are made from brass. The bottom image is a reminder of the difference between metals and alloys, alright? Have a go at these challenge questions. Metals are good electrical conductors, which is why the pins are made out of metals. Plastics are good electrical insulators, which is why the outer casing and also the wires as well are made from plastic. For the last question, you need to use the bottom pictures. The left is an alloy, and you should remember from our video on metallic structure that alloys are stronger than pure metals. This is because the atoms are not easily able to slide over one another. If you open up your plug, you will see this. When the current is high, the wire inside the fuse melts, which cuts off the current in the circuit. Here are these challenge questions for the section. Do you think? We can see that inside the plug we have 3 different wires, and the colors of these are yellow and green over here at the top center, blue on the left and brown on the right. The wire that's connected to the fuse is the brown wire, and this must be dangerous because if the fuse is used for safety when the current is too high, that must mean that wire must be pretty dangerous. So the brown wire is pretty dangerous. Let's summarize these 3 wires. The live wire, that dangerous wire, which is on the right, provides the current and it supplies 230 volts to the appliance. The neutral wire is on the left, and this is the wire that completes the circuit. The potential difference coming out of this is almost 0 volts. The earth wire is the middle wire. The potential difference is normally 0 volts if everything's going well, and this is connected to the metal casing of appliances so that you don't get shocked if things go wrong. However, some appliances like ceiling lights do not have a earth wire because they don't have a metal casing, so there's little risk of an electric shock. Here's a past paper question. See if you can collect the 2 marks that we need here. Diagram 1 shows a hairdryer. Diagram 2 shows how the heaters and fans of the hairdryer are connected to the 3-pin plug. The hairdryer does not have an earth wire. What color is the insulation around the wire connected to the live pin inside the plug? You should have said that the live wire is brown. Remember, that's that dangerous wire on the right. Why does the hairdryer not need an earth wire? We can see that the outer casing is made of plastic. If this was 2 marks, the next mark that you get is saying there's a little chance of an electrocution. The next part of the question is here. See if you can collect all the marks. All the switches are in the off position. Which switch or switches have to be on to make only the fan work? The current is coming out of the plug, and to form a complete circuit only around the fan would mean that we only close switch 1. To get the heater in position 2 to work, both switch 1 and 3 must be on. The heater can only be switched on when the fan is switched on. Explain why. The reason for this is that switch 1 needs to be switched on for the heater to work, and switch 1 also turns on the fan. This gives you your 2 marks. Here's a different question. Figure 2 shows how the mains electricity cable is connected to a washing machine. The earth wire is connected to the metal casing of the washing machine. If a fault makes the metal case live, the earth wire and fuse inside the plug prevent the mains cable from overheating and causing a fire. Explain how. This is worth 2 marks. The current goes from the live wire to the earth wire. That's your first mark. So that earth wire is going to carry it away from the metal casing. And the fuse melts. Remember, as we saw earlier, it breaks that circuit, so there's little risk of a fire. And there we go. The mission is complete.
Fatality.
Check the descriptions, use the timestamps to go back where you need to go, and I'll catch you guys in a bit.